Hello, I am Mr. Johnson. This is Introduction to Chemistry. We're going to talk today a little bit about what chemistry is, and then we're going to talk a little bit about what's called scientific notation. Okay, chemistry does a lot of things in your life. Even though you don't realize it, there are a lot of things that chemistry affects in your everyday life, and there's also a lot of jobs out there that pay really, really well that involve chemistry. Okay, this is hopefully your very first introduction to a real chemistry course. It may be the end, it may be the very beginning for you, but there is a lot of information here just about some of the different things that chemistry involves and also some of the jobs that involve chemistry. One of the things that we do a lot in chemistry is we use really, really big numbers and we use really, really small numbers. And when we use them within what's called the metric system. Okay, and here in the United States, we don't use it. We use gallons and pounds and miles, whereas in most of the world, they use liters, grams, and meters. So in science, we're going to use that as well. And again, in chemistry, we use really, really big numbers, and we also use some really, really small numbers. Okay? So one of the things that you're going to have to do a lot in this class is you're going to have to put a number into scientific notation, and you're going to have to take it out of scientific notation. And scientific notation is just a way of taking a number and getting rid of those unnecessary zeros. Okay, when you write a number such as 25 million, or let's keep going even more than that, 25 billion, you got a whole bunch of zeros here that, gosh, it'd be nice if you just didn't have to write those. Or sometimes you write a really, really small number about, something like this. Okay, and again, those zeros really are only there, and these zeros are only here just to show you where the decimal point is. The decimal point is right here at the end, even though we don't write it on whole numbers. And the decimal point is obviously here on that really, really small number. So what we're going to do is we're going to basically compact that, and scientific notation is to get rid of those unnecessary zeros. And all you have to do is you just have to count. How many spaces do I need to move that decimal point to make it so it's a number between 1 and 10? It has to be equal or greater than 1, but it has to be less than 10. It has to be just one digit. So basically, it's how many digits do I have to move this decimal point? Well, clearly, to make 25 billion a number between 1 and 10, I'm going to have to move this decimal point from here all the way to right there. And by moving it there, notice that my number is now 2.5. And that is a number between 1 and 10. It must be a number between 1 and 10. Same thing here. Where do I move this decimal point to make it a number between 1 and 10? Right there, 1.86. Okay, and then we just have to count how many spaces did we move that decimal point. For example, on 25 billion, we moved it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spaces. So I'm going to write that as 2.5, my number between 1 and 10, times 10 to the 10th. Okay, and then on this one, I'm going to write 1.86. Notice all those zeros are gone. Times 10 to the, and now how many spaces do I have to move this decimal point? 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm going to put to the negative 9th. Okay, and I want you to notice, and I do a couple more examples right here as well that are pretty similar to the two that I just did. Okay, notice in the examples that I did that one of those exponents is positive. Okay, notice that this number up here was a positive 10, whereas down here that was a negative 9. Okay. Okay, when the number is greater than 1, what do you mean greater than 1? Look at this number, 25 billion. Is that greater than 1? Of course. Then the exponent is positive. Okay, when the number is less than 1, such as right here, 0.000000, yeah, of course that is less than 1, then the exponent is negative. Okay, let me just do some examples here for you so you can see it. In these first 5, I'm going to convert those to scientific notation, and then the next 5, I'm going to take them out of scientific notation. If you want to try these first before I do them, that's great. And then you can check your answers. So go ahead and pause the video at this point. But if not, if you just kind of want to follow along with me, that's also fine. So remember, the first thing is it has to be a number between 1 and 10. So instead of 0.0153, I'm going to move that decimal point. So it's 1.53. And that's the only place it can go. It can't go between the 5 and the 3 because that would make it 15.3. It can't go after the 3 because that would make it 153. It has to go between the 1 and the 5. Okay, and then I have to move that decimal point 2 spaces, right? 1, 2 to get it between the 1 and the 5. And because the number is less than 1, it's a negative exponent. So that is 1.53 times 10 to the minus second. Okay, for letter B, it's 2.5. And remember on whole numbers, even though we don't put the decimal point, it's at the end of the number. So I have to move that decimal point 1, 2, 3, 4 spaces. And because it's greater than 1, that's a positive 4. So 25,000 is written as 2.5 times 10 to the 4th. Okay, letter C is going to be 1.05. I'm going to move it to right there. And then I have to count 1, 2, 3, 4, 5, 6, 7, 8. I'm moving that 8 spaces. Oops, I forgot the times 10. Sorry about that. Times 10. And because it's a number that's less than 1, it is a negative 8. Okay, letter D is going to be 4.1. Again, that's the only place I can put that decimal point to make it between 1 and 10. Times 10 to the, and I'm going to do this a little bit quicker, 3, 6, 7, 8. So 4.1 times 10 to the 8th would be the correct answer in scientific notation. Now this one you wouldn't ever really do in scientific notation, but you can. That would be 6 times 10, and we have to move this 1 space to the right, so to the first. And because it's less than 1, it's 6.1. Sorry, that's supposed to say negative 1. 6.1 times 10 to the minus 1. Okay, now over here on this right-hand side, we're going to put these numbers back into decimal form, which means we've got to move that decimal point the number of spaces it has up here. We've got 3.02, and with that 8 there, we've got to move that decimal point 8 spaces, and because it's positive 8, not negative 8, we know the number has to be bigger than 1. So we're going to move that decimal point 8 spaces to the right. So 1, 2 gets me to here. 3, 4, 5, 6, 7, 8. And the reason I do it that way is because then I know every little curve down is a 0. So then we put 1, 2, 3, 4, 5, 6. And make sure, guys, make sure you move that decimal point. Okay, don't leave the decimal point where it was. You've got to erase it from right there once you move it. Because with the decimal point, even though we don't write it, is way down here now. Okay, so don't leave it as 3.02 because it's not 3.02. That number is 302 million, where again the decimal point is at the very end. Okay, letter G, we're going to start with 6.25, and we're going to move that decimal point 4 spaces, and because it's a negative 4, we're going to move it 4 spaces to the left. So 1, 2, 3, 4. Put that decimal point there. 0, 0, 0. I'm going to erase that decimal point from there. So it's 0.000625. 9.94 times 10 to the 1 means that we've got 1 space to move it. And because it's positive, it's got to be greater than 1. So instead of 9.94, we just move that decimal point 1 space to the right. So it's 99.4. Okay, and again, would you do that with normal scientific notation? No, you wouldn't. But again, we do need to know the rules. Okay, and then even letter I, 2.25 times 10 to the 0 means don't move that decimal point any spaces at all, so it's just 2.25. And then our final one, 8.22 times 10 to the minus 10th, means I'm going to start with 8.22. Because it's a negative 10, it's got to be less than 1, so I'm going to move that decimal point 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I move that decimal point 10 spaces to the left. I'm going to erase it from there. And I erase that whole line, unfortunately. Okay. So we've still got our 822, but then I've moved that decimal point 10 spaces to the left. which makes me end up with 0.00000000082